Okay, hello everybody. My name is Marko. I come from Slovenia, from a company IRNAS, and yeah, so this is 99 projects with Zephyr. We do a lot of Zephyr, and I think we're coming up close to this number, but 99 sound a really good way to have a title. So short agenda. I'm gonna talk a little bit about IRNAS and me. Why we moved to Zephyr, why we are advising our clients to move to Zephyr, and some common challenges of modern firmware development that we ran into while developing applications, and also some resources for you to, if you're interested, to where to go look for. So who are we? We are a cross-disciplinary team of 16 engineers. We have 10 years of development of connected hardware projects, and we have an in-house infrastructure built for agile hardware and development. We often say, sorry, let me just disable this somehow, because it's running separate. Okay, let's see if it's going to continue to do that. We often say that we bring the clients. Yeah, no, it's not doing. Does anybody have some experience with this, solving this? Slideshow settings. This sounds like it. Animation, full presentation always on top. Change slides. Okay.
Trying to change slides manually. There was a checkbox for change slides manually. That sounds promising. The first checkbox in options.
Yes. Yes. This should be good. Let's see. That's good. Okay. So we always said that we are able to develop a device and connect it to the cloud. So we have in-house we are able to manufacture the device from the point of the hardware, so enclosure, mechanical enclosure, plastic enclosure. We can provide the electronics for it, and we can provide firmware for it, and also some basic rudimentary software that the clients require for, I don't know, provisioning, to connect to devices, to talk to them. We developed connected products for various different industries ranging from animal trackers to medical industry to optical systems. So a really wide range of different applications and use cases. We use a lot of different technologies in our products, and we are mostly let's say expert in Nordic chips. So we are mostly using Nordic chips to develop our products, and also since I think 2 years ago or 1 year ago, we are also a Zephyr Silver member. So that's about IRNAS. So about me, I'm electrical engineer by education. I started working at IRNAS for 5 years. Before 5 years, I started as a PCB designer, as an assembly engineer, and worked my way up to the firmware engineer. So I have seen so this is like a traditional, let's say, double E turned into the firmware engineer. So yeah. So this is how our transition of the firmware stack looked at IRNAS. So I think like 5 years ago, we were writing our applications on NRF5 SDK, a little bit before that even in Arduino. And about 4 years ago, we made the transition to the NCS and thus Zephyr. So, and we saw that Zephyr was the way to go, that it's slowly gonna get momentum, and we really were looking how to efficiently develop the various applications. And yeah, so on this slide, I had tons of bullet points, and a lot of the talking points were actually being discussed here already. And when I was thinking about this, like for us, actually, it's really this. Our added value is implementing business code. Nobody comes to us because they're like, hey, I really, really want you to write a device, to make a device that talks through the lightweight M2M. They have no idea what lightweight M2M is. They say, we want this device to talk to the cloud and to send us some data. And we're like, OK, cool, we know how to do that. And we know how to solve your specific use case. And Zephyr allows us to do that because we can reuse what the community developed. And like the previous speaker said, it's like configuring and taking the Legos and building up the application. And in the end, we can focus on the business code, not specifically the drivers. Of course, if the drivers are not available, we write them. So there are some challenges that I don't think there are specific to the Zephyr. I think they're just like modern firmware development that we ran into and we kind of solved them along the way. And those are like 4 general categories, and there are many more, but due to the time, I will only focus on those ones. So first one was how to implement and maintain CI across different projects. So we have, by average, we have between 10 and 14 projects running concurrently at all time. Some are in the active phase, some are in the, let's say, fix the bugs phase. And of course, we would like, at some point, we had no CI. We were like, we want to have some kind of a CI to support our development process, to support our building, testing, and releasing. So the challenge was how to actually write this if every single project is slightly different, like updating the workflow files in this way, it's going to be a little bit of a nightmare. So the setup that we thought of to do is basically agree what is, decide to have really agnostic, so we are working on the GitHub, decide to have really agnostic workflow files. So it does not matter what is the project. The workflow files are there. We have specific ones for the building, for running the twister, for running the code checker, creating a release, and publishing a release. None of those files depend on some specific WAS commands or some specific shell commands that your project needs. They depend on the makefile targets. And those makefile targets are found in a makefile that is inside of the project, and that is specific to that project. So what I tell to my engineers is go to the project template, download it, and configure it for your application. If your project is one single application, great, just leave the stuff as it is there. If you have two applications for that project, sometimes that happens, then add just another one inside, and you will have your CI running in no time. So that's like one setup that is doing us quite well. So this is like a general. So the next one was how to ensure good code quality and design across the team. So in those 5 years, we kind of grown as a team. We learned what are kind of the good practices, what are kind of the bad practices. And one thing that is really avoids a lot of time waste is actually doing like design sessions before the code reviews. So instead of saying, okay, yeah, we're doing code reviews, sending someone to the colleague, and the colleague is like, what is this? I have never seen this before. I have zero context how I'm supposed to approach this. Spend an hour talking about the problem and figuring out just with the pencil, just with the whiteboard, how are you gonna tackle it. Sketch the idea, you talk with the person, you get another pair of eyes on it, you refine the idea, you document it. That's quite also important part, so you can refer to it back later, and then you implement it, and then you do the code review. That way, a lot of the mistakes that are usually found in the code review are found in the design sessions, which is usually the cheapest way. So the other part are the code reviews. We generally try to focus them. We really prefer smaller PRs with up to 400, 500 lines of code, ideally less. And we often say that the reviewer should take maximum 1 hour per pull request, and that should be it. Everything more than that is usually the people start losing focus with that. We use stacking as a kind of a workflow, as kind of a development workflow. Not, as far as I know, this is not so known in embedded community. It's essentially creating branches, creating PRs out of the PRs that are existing. That way you can you are essentially not being blocked by waiting for somebody to review your code. You can still keep working on it. The tool that we like to use is Graphite for that, but it's not the only one that is able to do that. And also you can do this with bare Git commands. But it enables us basically to have like asynchronous code reviews where people are not waiting for each other. And also, yeah, automate the code formatting, linting. Agree what your code style is going to be and what the rules are, and codify them in the tool. And don't rely on individual editor settings. Use something like pre-commit tool to ensure compliance to the rules. So for those that don't know, the pre-commit is basically runs every time when you want to commit something. It runs a list of checks on top of your code. So for example, clang format, clang type. It can check if your commit message follows some kind of conventions that you set up. So it runs automatically and also helps you with setting up the tools and installing them on your host machine. If you don't know where to start with the code style and the rules and everything, just open Zephyr, find the coding section there. It's a wonderful starting point for the documentation. Nordic has a good documentation guidelines. Benefits from that, uniform code is easier to review. So it's like all the people speak, it feels like all people speak the same dialect, and that is much easier to understand. And there is no my code, their code mentality. So it's much easier to go and be like, okay, I can fix my coworker's code, and it's not like I need to ask him to understand what is going on. I can understand what is going on by myself. Yeah. So how to speed up the build setup and release process. So we are doing this in two ways. One way is the tool that we developed called East, which is built on top of West. I gave a talk about it last year in Prague. There's also a YouTube video about it. It's leveraging the Nordic's toolchain manager to provide sandbox environment, not like Docker, more like Conda. So some tools that are the tools that are not installed inside by default, it's gonna there's not like a really hard sandbox environment in there. So some of the system installed tools are still available inside it, but it still helps you to basically be up and running in 10 minutes instead of getting through the getting started section and running the commands manually by yourself. It also supports automated release artifacts. So there is one command you call East release, and it's going to build all the software that you need, all the firmware that you need that consists of it's basically your release, and it's going to prepare it in a nice zip package so you can upload it on a GitHub page, GitHub releases page, and it also contains some commonly used developer utilities. What we are also looking now into is Docker, because East, by extension, the NRF toolchain manager only provides build-specific stuff, so like compilers and some Python versions. But sometimes you need something more than that. Sometimes you need a specific version of code checker. Sometimes you need some specific version of the Sphinx tool to generate documentation. So in that case, Docker is a much better solution. So a lot has been said about developing the hardware and using the native SIM and using the native POSIX builds. So this is my take on this. So you can also develop specifically hardware drivers by using the native SIM, by directly interfacing with that chip or whatever device that you want to talk, by having the computer directly talk to it. So the issue in that case is usually how you're going to do the interfacing part. So you do require some external component. For the UART, is usually that's the simplest problem, because almost every single embedded developer has at least 2 USB to UART dongles in their cabinet. But there are some other, let's say, products or boards that you can buy that are basically USB to I2C, Aardwork, or similar. So the benefits there are that it's faster to develop and debug. You don't have to flash the code on some kind of board. You have better debugging tools, and you also have a simulation support. Drawbacks: additional work. You need to write some kind of a logic, some kind of a glue code on it. So it's important to think about like how much work you're going to put in and the return on investment. Really quickly, this is the example of that. A while ago, we were developing a product that was using a note card, which is a cellular Wi-Fi modem. The main microcontroller talks to this thing via UART, and the note card has a JSON-based interface, so it feels very web-like development. The device actually is quite complex and it requires good testing. So if you were running this on your actual hardware, it would take quite a long time. The manufacturers of the note card provide Node C library, which is, I see it as a utility wrapper around JSON commands. But if you're writing yourself, you end up with kind of a block like this. You use the Zephyr's UART API, and then you write some kind of a additional layer on top of it to make everything fit together. But still, you have to flash this on some kind of a chip every time. But can you run it on a host? So that was my question. And I knew that you could talk, that native POSIX at the time could talk to the pseudo terminals. And I was wondering if also the Linux serial ports were supported. And at that time, I figured out, no, those are actually two different things. ACMX is not a pseudo terminal. So I actually implemented one of my own. And essentially, the box on the right was the result of that. I wrote a new UART compliant API driver that was just using Linux serial port driver. And essentially like that, immediately everything started talking. Yes. So long story short, there's another feature there. Yes, that's what I wrote. So all the resources are here. If you're interested in anything of this that I was saying, come talk to me. Thank you.